first have to manufacture the silicon wafers by refining quartzite into pure silicon, and then growing a monocrystalline ingot and cutting it into wafers. For reference, these 300mm wafers are around 3/4 of a millimeter thick. Furthermore, these wafers are incredibly delicate and shatter into hundreds of shards when broken. A single wafer costs around $100, but after being populated with CPUs, it's worth closer to $100,000, making it quite literally 10 times more valuable than its weight in gold. Moving on to the steps after chip manufacturing. The completed wafer is sent to a separate building where each of the CPUs undergoes rigorous testing to figure out if it works as intended. If the CPU works, that's great, but frequently, a particle or photomask defect has damaged a section of the integrated circuit, rendering that section defective. These semi-functional circuits are then categorized or binned based on what still works. These Intel 13th Gen processors are sold as an i9, i7, i5, or i3, depending on how many cores are functional with different product lines of CPUs whose onboard integrated graphics sections are defective. These wafers are transported to another building where the chips are cut out using a laser, flipped over, and placed on an interposer, which distributes the connection points to a printed circuit board, while a protective heat-conductive cover is placed on the backside. The printed circuit board holds the landing grid array that interfaces with the motherboard, as well as various electrical components. Next, an integrated heat spreader is mounted on top, and the entire assembly is tested one last time before being packaged for sale. Finally,